Look at that. Brownie points. Oh, man, look at that. Look at that.
I'll move forward one.
Nice.
We like the back row though. Do I have to move forward? No. Just kidding.
Okay, well, that's right. All right, so okay, so here's to put things in perspective. Here's what we're doing now. We're gonna move on, and we're gonna essentially skip 5.5. We'll go back and maybe do a couple problems in 5.5. But there's a different way I like to approach quadratic equations. You know, teaching these analytically, thinking about it in terms of ways to solve quadratic equations, because that has been our focus so far in this chapter. We're going to shift gears later, but for now, that's still what we're focused on. We have a couple options. Up until today, we have a couple options. If we see a problem like this, what do we do?
Put them all to one side.
Okay, put everything on one side. Good, because, and the reason we're doing that, sure, we're combining like terms, and that makes things look simpler, but ultimately, the reason we're doing that is because we want to get this thing equal to 0. We want to get it into standard form, equal to 0. So if I push everything left, notice what we get. We get 0 on the right. Everything cancels, right? On the other side, 2x squared minus x squared gives us x squared. We get just a plain old negative 2x, and then negative 3 and negative 21 combine to negative 24. Okay, good. And recall the reason that we're doing this. I mean, we're going to combine like terms no matter what when we're solving. But now when we get to this point, we see that we can't combine them any further. We are stuck with two different x terms that can't be combined, so I cannot point to a single x. And therefore, I cannot isolate x. I have to do something different. And our something different, you might recall, is break it apart into small pieces, small factors that I can set equal to 0. So that's our new goal then. We want to see if this can be done. Can I unfoil this? Now, it's a simple question to answer. We always want to try it. If we have a simple-looking quadratic equation like this in standard form, where the number in front of x squared, which we call a, is equal to 1, and you always want to just quickly check to see if this works, if I can find magic numbers and be done with it. What do the magic numbers need to multiply to here? Well, almost. Negative 24, and they have to add to
Negative 2. So
negative 2.
Is bigger than this positive.
Okay, and so what would those two numbers be?
Negative 6 positive.
Negative 6, positive 4. And so we're able to find them pretty easily. Now, what are by the zero product property then, what we really want to know is, instead of this great big quadratic expression, we've traded it for a product of two simple linear expressions, linear factors. The product of these two is 0 when either the first is 0, which is when x is 6, good, or the second factor is 0, which would be when minus 4. And that's just our zero product property. So there's our trick. It worked great. Now sometimes, however, it's not going to work great. Sometimes we're going to get stuff like this. X squared minus 2x minus 23 equals 0. And try as we might, we're not going to find two numbers that multiply to negative 23 and add to negative 2. At least not rational numbers. They're going to be weird numbers. And we don't have a technique for that. We can't factor it, so up till now we've had to just say, can't do it. Can't factor it. We're done. Okay, today we can move on a little bit. The other ones we looked at were problems like this. Okay, now how do we solve this one? This is a different kind. Easier, I would say. Good, so we're going to isolate x. I can point to a single x, so we should be able to isolate it by pulling everything off of that side, reversing order of operations. So the first step is to subtract 3. Right? First we add subtract. Then what? Divide by 2. Good. Then what? Square root. Then what? Add 1. Good. Now, this may or may not work for you, but I think models like this are great if you can develop them internally. This what makes people really good mathematicians. You know what the rules are. We're going to reverse order of operations, so add, subtract, multiply, divide, undo exponents, and then finally deal with parentheses. But you can almost think about it like a chemical bond or something in chemistry. You want to think about the things that are easiest to rip away first, and then we'll just gradually work harder and harder to rip away the things that are more firmly attached. Adding 3 is pretty wimpy. That's easy to get rid of, isn't it? Dividing by 2 is a little bit harder, but still pretty easy. Right now, we got to undo a square root. That's like a more serious bond. We got to really work at that to get rid of that, and then finally, to get inside the core of this thing, we had to do all that work to get into the quantity that's in the middle. So if you can kind of build little models like that, I mean, it's look for those things because that's helpful. It gives you a feel, kind of an intuitive feel for what's going on. But you know what to do. You guys are getting really good at this stuff. So if we do those steps, we get what? 2x minus 1 squared equals negative 10 if I subtract 3. Divide by 2. X minus 1 squared equals negative 5. Right? Now, what about the square root step? This is a tricky one. There's 2 things that you could mess up on here. Okay, there's one thing that's coming, it's going to be an I probably. What's the other thing that, even if we don't get I's, we always have to remember if we're square rooting both sides?
Plus or minus.
Plus or minus. Square root of negative 5. And we know that's easy to deal with now. We've practiced this. When we're taking a square root of a negative, what do we do? Yeah. We're just going to factor out that square root of negative 1, call it an I, leaving us with the square root of positive 5, right? So then we just end up with x minus 1. And let's get rid of the parentheses now. We don't need them anymore. X minus 1 equals plus or minus I times the square root of 5. Last step, add 1 to both sides. And remember that it doesn't really matter. I could say plus or minus I radical 5 plus 1, but it's easier when we're adding or subtracting from both sides to put that number in front of the plus or minus. So our final answer, x equals 1 plus or minus, I'm going to flip these around for just a second. And it doesn't matter. Either way is fine. Oops. To make a point. Look at those answers. I want you to notice something about these. They're imaginary. They're complex numbers with imaginary parts. But if I split those up into the 2 separate numbers, the 2 separate solutions that we really have, we either get x equals 1 plus the square root of 5i, or x equals 1 minus the square root of 5i. Now, what can you tell me about those 2 numbers? They're pretty similar. What do we call numbers like that differ only in the sign between the 2 terms? Say it again? No, I mean, almost, not quite. When we have something like this, if we have a plus b and a minus b, what do we call those? What's that word?
Inverse.
No, it starts with a C. You can get it first. C. O.
You're thinking in terms of kids.
C-O-N. Oh, what did I hear? Conjugate. Close enough. Conjugate. So these are what we call complex conjugates, right? There are 2 numbers that look like these are in standard form. They're a plus or minus bi. This is not an accident. This is always going to happen. If you get an imaginary answer, imaginary solution to a quadratic equation, what we're going to find is they always come in pairs. They always come in complex conjugate pairs. And we'll talk more about that later. That's always what you're going to see. Okay? Now, what about the ones we couldn't do? There were some that we couldn't do, one like this guy, right? And then I could give you another one that maybe we could do, but we don't even really want to try. What if we want to do something like this, let's say, 8x squared minus 12x minus 16. That would be a good one. Minus 21. Yeah, that's fine. Now, if we were going to take a crack at that one, back in section 5.2, you would have been just thinking, oh my gosh, that's going to be terrible. And you would have been partially right on that, because those are hard. To do these kind, where I can't factor out a greatest common factor, I'm stuck. I've got an 8 in front of the x squared. Think of all the factors of 8. 8 and 1, 4 and 2, 2 and 4, 1 and 8. I got a 21 here. I got a couple different factors of that. There's a lot of different ways that this thing could be broken apart and unfoiled, aren't there? The technique we had, remember, was 8 times c, then split b. It's pretty hard. The numbers get big. So why don't we just not do it? Why don't we not do it that way? Because it's kind of hard. If we're going to come up with a technique for solving this one without having to factor, that same technique ought to apply to this one. And it does. Here it is. Here's our silver bullet. Quadratic formula. If you have a quadratic equation written in standard form, so ax squared plus bx plus c equals 0, where a and b and c are just the coefficients and the constant, right? The answer is always, always, never fails, going to be given to you by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by, the division line, the bar goes under the whole thing, divided by 2a. Okay, it looks like a lot the first time you see it, but in about 2 minutes, you'll never ever forget this. Because I have a little...
It's a song, isn't it? Uh-oh. It's the baby video.
I have a little secret weapon,
Should I be afraid of it?
which is right on the Moodle page.
I think I should be afraid.
I think we shouldn't watch it.
So sorry for everyone who's not in this class.
I know it.
Hi, boys and girls. Are you ready to learn the quadratic formula? Cool. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Isn't this fun? This is great. Let's try it again. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Let's do that again. Let's try and make it a little bit different. I don't know. Make it a little rockish. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Cool. Maybe we can sing it a little bit faster. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. That was fun. Let's try it a little bit slower. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Oh, that was so nice, so sweet. Let's just sing it one more time. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Divided by 2a.
Yeah.
Need a break from that.
No, sorry.
That video for my dad. So I have a question. Did Quinn put you up to this? Can we answer this question? Because I haven't seen him.
Okay. So let's do this now. Here's a problem that a few minutes ago we couldn't do. Now we can do it quite easily. What are the values of A and B and C? This is in standard form, right? It's set equal to 0. Good. So A is 1, B is -2, C is -23. And let's see how good your memory is. If I've got something in the form ax squared plus bx plus c equals 0, the quadratic formula tells me that x equals...
Oh my God. Could you have taught us that in a way that's less traumatic?
B squared minus 4ac divided by 2ac.
There we go. Okay. Beautiful. Beautiful. So if we plug these numbers in, so if we just plug in these numbers, we're going to get an answer. All we have to do is simplify. And the only part that's tough at all, it's not really hard, is the part inside the square root. We just have to simplify a radical, but that's it. There's not much to this at all. So we just end up getting then, if we plug this stuff in, whoops. If b is -2, what's negative b?
Shut up.
If b, once again, if b is -2, what's negative b? 2. Yeah, it means the opposite of b. So we're going to get 2 plus or minus the square root of, now b squared. We got to remember what we do when we're squaring a negative. What's our rule for squaring a negative? What do we always do? No, if we square a negative. Like negative, in this case, we got -2 squared. Yeah, we square the positive. You always just square the positive opposite. So -2 squared instead, we'll just put in 2 squared, like in our calculators if we're using them. 2 squared minus 4 times A times C. So 4 times 1 times -23. Okay? All divided by 2 times 1, which is just 2, right? Okay, so then if we want to simplify that down to a final answer, now we get 2 squared is 4. Here's another really easy way to simplify under the radical. Count the number of negative signs you're multiplying. In this part right here, we want to count the number of negative signs. If I have an even number of negative signs being multiplied, what does that tell you? If an even number, positive. If I have an odd number of negative signs, it's negative, right? So here I've got 1, 2, so it's positive. And then the number is 4 times 1 times 23, which is 96. So, let's see, is that right? 20, no, it's not, is it? 92. 4 times 23, yeah, 92. Okay, and then divided by 2. So I'm going to get 2 plus or minus the square root of 96 divided by 2. Okay. Now we could simplify that further. That's, you know, we can go further than that for sure. But that's our answer. Okay, let's finish it up. Let's go one step further. Watch the video again.
I agree.
It's nice.
It helps me. It's almost done.
Yeah.
I keep on forgetting the
Yeah,
last
I
one.
enjoy it.
Little so you can watch it. Don't feel it. I really felt it.
And I will kill you if you tell me to pop. No shit, kill me though. Actually, I don't think kill me for killing somebody.
Okay, let's simplify the square root of 96. Oh, here we go. Right. Let's simplify the square root of 96. Now, ideally, we'd like to think of the biggest perfect square that divides into 96, but we don't have to get the biggest. If we don't get the biggest, we just have to do it again, though. So let's kind of, now here's a strategy for doing this. If we work backwards through the perfect squares, we can disqualify big ones pretty quickly. So you know the perfect squares. 4, 9, 16, 25, keep going. 36.
42.
Okay, now I'm going to stop there. I'm going to stop there. Here's why I'm going to stop there. Because is 96 a perfect square? No, it's not. So then the biggest possible perfect square they could divide into 96 has to be half of 96 or smaller, right? So then 49 is already bigger than half of 96. So we can cross that one out. We don't need to go any further. Does 36 go into 96? Nope. 25? Nope. 16? 16 does, doesn't it?
Yeah, 16 and 6.
16 times 6. Okay, so then we could break this up into
6.
square root of 16 times square root of 6. Square root of 16 is? Okay. Okay, last step. Here's another one here's a very, very common mistake people make. What do we do here? We can go a little further with this. There's a couple ways we can think about this. We could divide this into separate terms, break it into separate fractions and simplify each one separately, or even better, what we can do is we could undistribute a 2 from both terms on the top. So I could factor out a 2. So that's going to look like 2 times, if I undistribute it, I'm left with a 1 plus or minus 2 square root of 6, right? Everybody agree with that? If I undistribute the 2, right? If I divide a 2 away from this term, I'm left with a 1. If I divide 4 by 2, I'm going to be left with a 2 there, right? Okay, now, listen very carefully, because this is probably maybe the most common, later Algebra 2 mistake for the rest of the year. This is probably it. I can do this. That is okay to do, because I can cancel like factors in the top and the bottom. Something that is being multiplied by everything else in the top may be canceled with something that is being multiplied by everything else in the bottom, or in this case, by itself in the bottom. So when I cancel those, that just gives me a 1 there and a 1 there, and I don't need that one, do I? And I don't need that one, right? So I'm left with, when I cancel those out, I'm left with, and my final answer is just 1 plus 2, plus or minus 2 times the square root of 6, okay? Now, how else could we have done that? There's another tricky way to do this, but you got to be very careful with it. I could have right here said, okay, as long as I can divide each term, if I can divide a 2 out of each of the terms that are being added or subtracted in the top, I could do this. Make that a 1, that a 2, that a 1. Okay? And that also gets me directly down to that answer. Now, what people have a tendency to want to do is this, which is wrong. This is okay. A plus AB over AC is equal to 1 plus B over C. I can cancel those A's because the A is being multiplied all the way through the top, right? In other words, I could factor the A out, and I'm left with 1 plus B, and then cancel the A's. That's okay. This is not. Here's what people want to do lots of times. A plus B over A, people want to call that something like 1 plus B. They want to do this. That is, can't do that. I can't do that because A is not being multiplied all the way through the top. The A only shows up in that one term. You see that difference? It doesn't seem like much when you look at it on paper, but it's huge. This is absolutely not correct. This is. Okay? Yeah, go ahead.
So yourself?
Wow. These are big steps. All right, this is good. Okay, try that one. Try one more and we'll call it quits. Try that one. Try that one. What's A? What's B? 2. What's C? Okay, keep going. Okay, so what do we get in the top of the quadratic formula then? What's negative b? Plus or minus square root 2 squared, square the positive. Okay. How many negatives? 2. So we're going to add. 2 squared is 4 plus 4 times 1 times 4 is just 16.
Auto yourself.
Okay, so simplify that, please. I'd like to get that down to the smallest answer. Quadratic formula part was pretty simple. What about the square root of 20? What can that become?
Square root of 4, square root of 5.
Square root of 4, square root of 5
2
becomes
square root of 5.
2 square root of 5. Okay, good. So we get 2 plus or minus 2 square root of 5 over 2.
Ooh, there we go.
What does that reduce to? Good. We can, as long as we cancel both 2's, we can cancel the 2's, right? So 1 plus or minus square root of 5
Yay.
over 1, which we don't write. Okay. And you know, we won't do another one, but if it's no big deal. If you want to go a step further than that, you know, we could do something like this very easily, couldn't we? Right? I mean, it doesn't matter if a is bigger than 1. It makes no difference. The quadratic formula works either way. Okay? All right.